Of course, after 2 weeks of being rock solid, my laptop decided to crash as I'm closing up, coming to the stage. So I'm stalling just slightly for preview to open. I'd also like to thank Zed first for such a great talk, and second for such an entertaining conversation about contributing to projects yesterday at the speakers dinner. Happy to be of service to other speakers. It's just firing up. I'm a qualified engineer. I can handle this. I just have things on my desktop I don't want other people to see, so I'm waiting for Keynote to fire up and block the whole thing. Okay, quick question. How many people use Postgres now in deployment with, well, cool. That's a nice... Come on. This is the there's an old joke in computer science that there are only two problems that are hard: naming things and cache invalidation. This is an excellent example of the cold cache problem, of how long it takes to do everything with the cache on the laptop being cold. And I'm watching the opening bar. Ooh, look. Okay. Bink. Bonk. And now, of course, the video won't work, and I'll have to summon someone up, and I'll be totally humiliated. No, ooh, look, there we go. Okay, great, let's get going. So this talk is titled Advanced PostgreSQL and Django. And that's great, but what am I really going to talk about? Which is, the feature is a lie. So suppose you want to paint your house. So, okay, you want to paint your house. So you go to a paint store, and you walk in, and you're standing in front of the paint rack, and the salesman, whose job it is to help you, comes up and says, well, what would you like? Have you decided on a color? And you turn to him and look at him as if he's crazy, and you say, a color? Well, no, I want all of them, because my house needs to be color agnostic. So this is the problem with database agnosticism. The offer is write once, run on any database. And it's a critical selling point of Django, and it's a good feature. It is a very good feature. I'm a Postgres guy, but that's okay. I use the MySQL backend. I do all sorts of stuff. And if you're writing a plugin or a tool that runs on, it's also. But for everybody else, maintaining database agnosticism where you're paying a price for it is a bad idea. Databases are really different, one from the other. They have different performance characteristics, they have quirks, they have strong points, they have bad points, except for Postgres, which has no bad points. And realistically, database migration, where you are a MySQL shop and need to move to Postgres, well, okay, that happens all the time. But all the other ones, is a very rare situation. But every day, you're paying the performance hit for not taking advantage of these features. So enjoy your database. Don't be afraid of using database-specific features. Every database has lots of them. And let's talk about some of Postgres skills, because I work for a company called PostgreSQL Experts, so I kind of have a bias. So, what can the elephant do for you? We're going to talk about custom types, custom indexes, custom constraints, lots of custom things here, and everybody's favorite, raw SQL. So custom types in Postgres. I'm going to go nice and fast because there's the one thing that is never forgiven is if you're the speaker right before lunch, running long. If you like types, you'll love Postgres. I got into Postgres. How many people have Oracle experience at all? I'm like an Oracle DBA in my 20th year of recovery. And remember the great date time handling Oracle has? No, that's because it doesn't have any date time handling. And I was looking for one, and I ran into Postgres, and it was an amazing experience because Postgres has amazing date time handling. But it has a huge range of other types too. And the best part is you can use them in Django natively, usually with an easy-to-find module. And if you don't have a module, integrating them in is really easy. So here's one real quick example. You have to do a query on an email, but you're storing the email as the user entered it with upper and lower case because you're trying to be nice and preserve their capitalization. But of course, you want to do a case-insensitive search. So you write one of those. I've done this all the time. Then you realize you need a specialized index just to make this work. Because if this is 25 million rows, that's going to take forever. And then you have to do a functional index, or you have to do this. And you're kind of wondering, so what career choice did I make that I have to worry about this stuff? Well, Postgres can solve this problem for you. It has a built-in module called ciText. Well, built-in the sense that it's part of contrib. It ships with all of Postgres. And it's case-insensitive text. It is exactly like every other text field in the entire world in Postgres, except it collates case-insensitively. And it solves this problem. The indexes are case-insensitive, comparisons are case-insensitive. Obviously, this is just one example, but this is a whole class, but you've just saved yourself an extra index, especially if that was a primary key. Completely indexable. The attributes problem. This is usually, so very frequently you're building a database and you have your columns and you have your model fields and everything's great. And then there's this stuff, like if you're building a package system, they want to have attributes that they add to each user. And these attributes are very sparse. Very few users have all the attributes, so it doesn't really make sense to make it its own column. And usually you end up building something horrible like an EAV table where it's user ID, attribute, value, type, and it's just horrible and it's messy to join on. And this is a really common problem. Very, very common if you're shipping a system that other people are going to customize in some way, but you don't want them monkeying around with the schema. And the traditional solution for this is a separate table, but that's gross. That's really horrible. So we have the Hstore type. It's also part of contrib. It's basically a built-in string-to-string dict type. Very nice, very convenient. It maps into a Python dict very nicely. PsychoPG2 handles, as of the most recent version, handles this for you. It can be indexed and queried for inclusion very easily, so you can query for particular values in the value side of the dict or particular keys, or both. And unfortunately, to do the querying, you probably have to write some custom SQL, but come on, we're all grown-ups. We can write a little custom SQL. As of the most recent version of Postgres, we have JSON as a built-in type, because, of course, all the cool kids are using JSON. You frequently want, even in a relational database, you want to archive JSON blobs. For example, you're logging, or the stuff is coming in as JSON. You're using JSON for document storage, again, for these very sparse types where not all the fields are enumerated, or it's deeply hierarchical. Or you want something faster than MongoDB to store your JSON documents. I have a talk comparing Postgres as a NoSQL database to MongoDB. I think it's kind of enlightening. So Postgres has a built-in JSON type. The JSON's validated going in, so you know it's at least syntactically valid JSON. Right now, the feature set is not super rich. We do have PLv8. You can add PLv8, the V8 JavaScript engine from Google, to do a lot of stuff. 9.3 is going to have a lot more built-in JSON support, which will be nice and fast. Plenty of others. UUIDs. It always kind of pains me when people use it. I like UUID keys, primary keys, a lot, because if you've ever had to merge two databases that were operating separately that used serial keys that both started from 1, you'll understand why UUIDs might be appealing. But it's always kind of painful to see, car 128s for these when it's a binary field. Well, don't do that. Use the built-in UUID type. Character strong. Oh, I was really tired. IPv4 and v6 addresses are built in. So if you're logging things like that, you can use those directly. You can also do comparisons for CIDR style comparisons on them, which is really nice. One thing that no one seems to take advantage of it is there's a built-in interval type in Postgres. So if you need to encode things like next month, you're doing a calendaring system, you can use that directly. And Postgres is super smart about these things. +1 month is not the same as +30 days, for example. And that's a very convenient thing to throw in. Craig from Heroku will be giving a talk later. He'll have lots more examples of this stuff. This is my apology for kind of stepping on the topic. Or define your own types. It's really easy to define your own type in Postgres, especially composite types. They're just records of things. You can integrating them into Python and Django is also really easy. Daniela, who wrote CyclePG2, has made this a really straightforward process. And you can even create custom indexes on these custom types. For example, if there's a record type that has custom comparisons, but you want a B-tree index on it, no problem. You can even write the index access functions in the indexing functions in Python if you want. So how do we do all this? There's kind of 2.5 steps to integrating a new type into Django. You adapt it into CyclePG2 so that now that maps it from the database type to a Python type. You write a new field class for Django, so you can dump it into a model. And if you want to use it in a form, you write a form field type. Interestingly enough, the structure of these is almost all the same. There's this thing about it takes a type on one side and it takes a string and turns it into a type. And you do that a lot, writing this, is this stringification thing. Adapting into CyclePG2 really is just, you take a string representation of the type and you convert it to and from the Python object. You end up writing regexes, unfortunately, for this stuff a lot, but oh well. CyclePG2 has a lot of examples about how to do this stuff. It's and also built-in types, like UUID is built into CyclePG2. You can do this for both existing and custom types. The field class is just a subclass of DB models field. It's if you've already written the CyclePG2 part, this is really easy because it basically does the same thing. Is this it wraps up the Python type so that the field can use it. It also tells it when it does when you do a syncDB what type to use. Then there's a form field class where you translate the external HTML type into the internal type. So again, you spend a lot of time writing these stringification and destringification methods. And if you also want a custom widget, for interval, you might want some kind of custom slidery thing. This is where you do it. So when it renders the form. And for complex types or things with interesting display characteristics. Okay, we've got now custom indexes, both on custom types and otherwise. The models are great, but the indexing creation syntax is somewhat limited. You've got, because there's all sorts of different kinds of indexes that there's no direct way of expressing in Django, like multi-column indexes, expression indexes. There's work going on multi-column indexes. I'm not sure where that is. Expression indexes, partial indexes, cool stuff. Unfortunately, there's no direct way in the model syntax to create these. That's a shame. You have unique together. That's pretty much it for interesting other kinds of indexes. One thing that is a really powerful tool is a partial index. A partial index is an index that doesn't index every single row in a table. It only indexes a subset of rows. And creating one in SQL looks something like this. It has this doodad with the where clause called a predicate. And as long as you're using a query that uses that predicate, it will use this index. Now, the reason this is nice is let's say there's only let's say this is every order that's ever been taken in the system, and only 1% of them are active. This index is now only 1% of the size it would be if you indexed every single row on this, and querying it, thus, is that much faster. So if the predicate is highly selective, that's great. Now, if the predicate is, for example, a Boolean and it's 50-50, a partial index isn't going to do you much good on that. But for highly selective indexes, it can be really great. Smaller index, faster access. If you query on multiple columns at the same time regularly, a multi-column index can be very valuable. Just index on A, B, and C. This accelerates lookups on just A and B, or A, B, and C. It doesn't help on B or C, though, which is kind of a shame. But there it is. For B-tree index. And if the columns are commonly used together, very helpful. And the last one is expression index. We actually looked at one of those with the lower function if you wanted to create an index on that. Here's one that creates one on just the year of a date field. If, for example, you're commonly aggregating on just the year, this could be a very big, this could help you a lot. If you use the same expression in the query, then an expression is very helpful. And you'll know you'll be doing this because you'll be writing custom SQL, because there really isn't any way in the standard ORM to write expression indexes. So, but where do you put this SQL? For example, to create an index or something like that. You can use the .SQL inclusion mechanism, and what you will do is you'll use that for a while, and then you'll write this really long statement and go, that looks really ugly, and put a carriage return in it, and it will break. And then you will spend half an hour Googling and discover it presents each line to the database independently, each text line. And you'll wonder why that does it, and you'll go to the bug report, and there's a long discussion which closes do will not fix, and you'll be very frustrated. And then you'll push that button, which I always do at least twice every presentation. And then you will do the sensible thing, which is use south. You are using south, right? Everybody's using south. Good. Nod, please. Okay, great. Because that's the most sensible way of staging custom SQL into the database. And custom constraints. Let's see. The constraint handling in Django is a great example of the problem of database agnosticism. I spent a long time tracking down a bug in a customer application because, as I am sure you all know, foreign key constraints that do cascaded deletes and things like that are implemented in the ORM in Django, not delegated to the database. The problem is, this can create really weird, interesting locking problems, especially if two separate sessions are trying to do this at the same time. So, you also have unique constraints, and that's basically all you get out of Django. And that's really not taking full advantage of what Postgres can do. Boring. So, let the database do this stuff. You should always push constraints into the database engine wherever possible. You want anything you can express as a constraint that actually does constrain your data, enter as a constraint. The problem is, even if you think right now the only way you'll ever update the data in your database is your application, you are wrong. You will do bulk loads, you will get a feed from somewhere, you'll merge it, and you want the checking to be in the database level so the data doesn't get broken by something that's not your application. Also, constraints are much more efficiently executed in the database than in your application. Obviously you want to do checking and things like that so you can perform the cutting in and out, that you can inform the user or throw the right exception, but you want to make sure that the database won't let you put bad data in. And it avoids this nasty locking problem for cascaded deletion on foreign keys. So, the first thing you do to implement this is say do nothing on your models, because that turns off the cascaded delete for foreign keys. And then just use the standard syncdb, it'll create the foreign key constraints for you. And then you can add the constraints at the database level, and you do something like this. This is like in a south migration. You do an alter table to drop the constraint, because you can't, and then you do an alter table to add the constraint, and this huge long thing, and at this point you're saying, Christophe, you are mad. You expect me to do this? And the answer is, yeah, that's a shame. It's unfortunately kind of tedious and error prone to do this. It would be great if there was a tool, which I'm in the process of working on. But for the moment, that's the way you do it. Just add the constraints back in manually with the right. It's unfortunate that you have to do it that way right now, but there will be a better solution. But that's just foreign key constraints. Let's talk about other constraints. You can create check constraints to enforce the data integrity at the database level. Who is familiar with exclusion constraints? They're a semi-new feature in Postgres. Ooh, not a hand that I can see. I'm sure there's some. Oh, there's one. Great. Somebody. Now, there's an interesting problem. Think about a unique constraint. What's it really doing? It's effectively saying, don't let this row go into this table if there are any other rows that equal this one in this field. Okay. Well, you can imagine generalizing that operation, saying, don't accept this row in if there are any rows for which this operator is true.
For example, let's say you have a database that has time ranges in it, because now Postgres has built-in range types. And you're doing a reservation system. You might want to say, don't accept a row if it's for the same room with a time that overlaps this time. Doing that with a traditional check constraint is basically not possible. But since Postgres has inclusion operators, like do these two time ranges overlap, you can write a constraint that does that. It's very nice, and it's really only with these that you can enforce constraints like that. And finally, raw SQL. So my personal rule is the 3 join rule. If you're joining more than 3 tables, drop into raw SQL. After 3 rules, let's face it, the Django query syntax is heroic, but it does get kind of gross. And SQL was kind of designed for this. These large join operations and massive relations. Just go to raw SQL. You'll be much happier. It'll be actually much more maintainable. And whatever you do, don't fall back into using multi-query sets and iteration just to avoid writing SQL. The database engine is designed for processing these large join operations quickly. Postgres has huge optimizations for getting this stuff to work. If you're going to do a query, come back, iterate over it. Get another query back, iterate over that. You will guaranteed be slowing things down. And if what you want back are real model objects, you can use the raw query set functionality, which was a great addition to 1.4, I think, 1.3. So here's an example. This is a obfuscated example of a real-life data model. It's actually simplified considerably. I was just working on this a couple of weeks ago. So we have L's, which have multiple C's, which then have this hierarchy of SCs, which then have a one-to-one relationship with an OS, and then multiple OPs, and this, blah, blah, blah. Okay, and then the problem is, for a particular L, I need to get the total number of O's with a particular status. It has a status field. And the highest status of all those O's for each C and SC in the L. And the first thing I did is, despite the fact I'm supposed to be this SQL guy, I sat down and wrote it all out in Django. And I have no idea what I was thinking. I was personally getting into, oh my God, I can't write SQL mode, which is kind of weird because it's what I do for a living. I enumerate all the C's and I recursively descended. I wrote these like really clever little functions in the model to do it too. It was great. And I got the OS and I got the OPs and I got the O's. And this took like 30 seconds to run. And this was trying to load a single page. So that wasn't going to work. Now, and that data model was was considerably simplified. And then I realized, wait, isn't there this thing called SQL that the database uses? Maybe I could do this in a single query. The comment, which doesn't fit on here, just says "behold" up there. I am particularly pleased by having a subquery that's recursive. That just was one of those moments database programmers live for. Now, not every raw SQL query needs to be this complex. However, there it is. It solves the whole problem in one database round trip. And if you're a reasonable person, you'll go, "Oh my God, I have to write that." However, that's the difference. You write it once, but forever you get that much of a speed up. And the only data that came back was that was actually required for the view, which was really nice. It didn't have to get back every object. And thousands of database round trips. There are other times you want to use raw SQL, like there are query operations you may want to do that are not specifiable in the native query language, like full text search or geometric queries. There are extensions to Django to do this stuff, so that's another option. But sometimes you just need to drop in and do this, and it's very handy. And this particular example, which is you have really complex joins, and you don't want to get back this whole giant mass of data. You're really only drawing 3 things on the form, on the web page. So just get back those 3 things. Don't choke the connection between yourself and the database with all this stuff. And whatever you do, don't create new models just to handle data slicing. So if you're reducing the data down, don't create another model to hold those. Just use tuples or dicts or stuff like that. It's fine. Where to put this stuff? Put the actual SQL in the manager or in the model. Don't dump it into the view because you'll never find it again, or you'll find it exactly the wrong time. If you feel comfortable doing this, wrap the stuff in stored procedures and dump them in the database. Use South migrations. I know I'm doing a heavy sell dial on South, but it really is the right answer here. To manage adding and removing the SQL, it's the right place to do it. There's also, if you're, as a generalized solution, there's a project called Skitch, SQITCH, for doing generalized database migrations, but if in a Django project, use South. So, to conclude, use the database to the fullest. Don't limit yourself because of hypothetical need. Frequently you'll say a boss saying, well, but what if we want to move to SQL later, move away from PostgreSQL or MySQL or anything else? The answer is, we'll worry about that when it happens. MySQL, Postgres, Oracle have, if for some reason you're stuck using it, they can handle databases of any size. So that's not the reason to move away. So make your decision once and just stick with it and use the engine as much as you can. Unless you're using MySQL, in which case you're definitely going to move off of it. PostgreSQL has a lot of advanced features to make your life super easy. So just use them. Lots of great stuff in there. And that's my talk.